Hello everyone, welcome back to EKD Memorial. So today we are going to start with question number 6 of CBSE 2024 mathematics paper. Okay, so question 6, it says that AD is the median of the triangle ABC with vertices A as 5, minus 6, B with 6, 4 and C with 0, 0. We need to find the length of AD. Now since AD is the median of the triangle ABC, so D must be the midpoint of B and C. How do we get the coordinate of D? The coordinate of D with the help of the midpoint rule is this, which is 3, 2. Now the length of A and D is 3 minus of 5 whole square plus 2 minus of minus 6 gives a 2 plus 6 whole square with an under root, which is this is 3 minus 5 is a minus 2 square is a 4. Okay, 6 plus 2 is a 8, so 8 square is a 64. So this is an under root of 64 plus 4 is a 68, so root over of 68 units. Now hopping on to question 7, it says that if sec theta minus tan theta is equal to m, then we need to find the value of sec theta plus tan theta. Now we know that from the trigonometric identity that sec square theta minus tan square theta is equal to 1. So which is of the form a square minus b square. Now we know that a square minus b square is actually a plus b into a minus b. So assuming sec theta as a and tan theta as b, we can apply this formula here and hence we get sec theta plus tan theta into a sec theta minus tan theta, which is equal to a 1. Now, given that sec theta minus tan theta is equal to m, so substituting the value of sec theta minus tan theta as m, we have sec theta plus tan theta into an m is equal to a 1. So, sec theta plus tan theta is equal to dividing this m to the right, we have 1 by m. Moving on to question 8, it says that from the data 1, 4, 7, 9, 16, 21, 25, if all the even numbers are removed, if all the even numbers are removed from this data, then we need to find the probability of getting at random a prime number from the remaining. Okay, so the data is 1, 4, 7, 9, 16, 21, 25. So after removing the even numbers from this data, we get 4 is an even number and 16 is an even number. So we get 1, 7, 9, 21, 25. Okay. Now, out of these 5 numbers, the only prime number is 7 because 1 is not considered as a prime number. So, the probability of getting a prime number at random is 1 by total number of outcomes is 1, 2, 3, 4, 5. So, it is a 1 by 5. Question 9. It says that for some data x1, x2 up to xn with respective frequencies f1, f2 up to fn. That is x1 has frequency f1, x2 has frequency f2 and xn has frequency fn. We need to find the value of summation of fi, xi minus x bar. This x bar is the mean of these class bars. Okay. So, x bar is given as summation of fi xi divided by summation of fi. Now, keeping the summation of fi xi and multiplying this x bar with the summation of fi, we get this. Now, this x bar is independent of this I and this summation runs over this I. So, we can take this x bar inside and hence we get summation of fi xi. Taking this term to the left, we get a minus summation of fi x bar is equal to a 0. Now taking the summation of fi common, we get that summation of fi into an xi minus x bar. This is the thing which is required whose value is a 0. Okay. So hopping on to question number 10. It says that the zeros of a polynomial x square plus px plus q are twice the zeros of the polynomial 4x square minus 5x minus 6. If that happens, then what is the value of this p? Okay, first what we do is we take out the zeros of the polynomial 4x square minus 5x minus 6. So first we factorize this polynomial and we get it as 4x plus 3 into an x minus 2. Now if we equate this with a 0, we get that x is equal to 2, and if we equate this with a 0, we get that x is equal to minus 3 by 4. So the zeros of the polynomial 4x square minus 5x minus 6 is actually 2 and minus 3 by 4. Okay. Now we are assuming that the zeros of the polynomial x square plus px plus q are alpha and beta. Now we know that if we have a polynomial of the term a x square plus bx plus c, and if alpha and beta are the roots of that polynomial, then alpha plus beta is equal to minus b by a, and alpha into beta is equal to c by a. So in this case we get that alpha plus beta is equal to minus coefficient of the x, which is a p, by coefficient of x square, which is a 1. So alpha plus beta is equal to minus p by 1, and alpha beta is equal to q by coefficient of x square, which is a 1. Okay. Now according to the problem, it is said that the 0 of this polynomial is twice the 0 of this polynomial. Now 1 0 of this polynomial is considered as alpha, and 1 0 of this polynomial is considered as 2. So alpha must be 2 into this 2. Okay. Another 0 of this polynomial is beta, and another 0 of this polynomial is minus 3 by 4. So according to the problem, we must have beta is equal to 2 into minus 3 by 4. Okay. So we get the values of alpha and beta. Now we substitute the values of alpha and beta here in equation 1, and hence we get the value of p, which is minus 5 by 2. So question number 11, it says the distance between 3 comma minus 5 and x comma minus 5 is 15 units. So we need to find the value of this x here. Okay, so we term that a and b are the 2 points whose distance is this 15 units. So length of AB is given as root over of x minus 3, the first coordinate and the first coordinate here. So x minus 3 whole square plus minus 5 minus of minus 5 gives a minus 5 plus 5 whole square. Minus 5 gets cancelled with a plus 5. So we are left with a root over of x minus 3 whole square. Now this AB is also 15 units. So root over of x minus 3 whole square is equal to 15. Now squaring both sides, we get this root gets vanished, and we are left with a 15 square here on the right. So x minus 3 whole square is equal to 2 to 5. Now again we are taking a square root. So x minus 3 is equal to a plus minus 15. So either x minus 3 is equal to a plus 15 and x minus 3 is equal to a minus 15. So x minus 3 is a 15 and x minus 3 is a minus 15. Now solving the values of x, we get it as minus 12 and 18. Question 12. It says that if cos alpha plus beta is equal to 0, then we need to find the value of cos alpha plus beta by 2. Now cos alpha plus beta is equal to 0. Now cos pi by 2, which is a cos 90. Cos 90 can be also written as 0 because value of cos 90 is 0. So 0, we are writing it as cos 90. So cos alpha plus beta is equal to cos 90. So the angles must be equal. So alpha plus beta is equal to pi by 2 or 90 degree. Now alpha plus beta is pi by 2. So alpha plus beta by 2 is a pi by 4. So cos alpha plus beta by 2 is equal to a cos pi by 4, which is a 1 by root 2. Question 13. It says that a solid sphere is cut into two hemispheres. So this is the solid sphere that is cut into two equal hemispheres from the middle. Okay, so we need to find the ratio of the surface areas of the sphere. So surface area of the sphere, this with radius r is 4 pi r square, and to the two hemispheres. Now surface area of one hemisphere is 2 pi r square plus this circular disc here. So 2 pi r square plus pi r square. So surface area of one hemisphere is 2 pi r square plus pi r square, which is a 3 pi r square. So surface area of two hemisphere is 2 into this 3 pi r square. So it is a 6 pi r square. Now we need to find the ratio of the surface areas of the sphere, which is a 4 pi r square, to that of the two hemispheres, which is a 6 pi r square. So 4 pi r square is 2, a 6 pi r square gives a 2:3. Question 14. It says that the middlemost observation of every data arranged. Now, the middlemost observation of every data arranged is known as the median. So, the correct option is median. Okay. Question 15. It says that the volume of the largest right circular cone that can be carved out from a solid cube of edge 2 cm is. Now, we have a cube of 2 cm. Of edge 2 cm. Okay. Now, we need to find the volume of the largest right circular cone. So, we need to fit a cone here, or actually we need to carve out a cone out of this cube of edge 2 cm. So, this is the diameter of the base of the cone. So, the diameter of the base of the cone is actually the edge of the cone. Now, diameter of the base of the cone is 2 cm because it is equal to the edge of the cone. If diameter is 2 cm, so its radius must be divided by 2, which is a 1 cm. Now, see, this is the height of the cone, right? Now, this height is equal to another edge of the cube. So, the height of the cone is also 2 cm. So, the volume of the cone is 1/3 pi r square 8. R is a 1 cm and 8 is a 2 cm. So, we get it as 2 pi by 3 cubic centimeter. Question 16. It says that two dice are rolled together. What is the probability of getting sum of numbers on the two dices as 2, 3 or 5? Now, the total number of outcomes when two dices are thrown is 6 into 6, because one dice has an outcome of 6, 1, 2, 3, 4, 5, 6, and another dice has outcome of 1, 2, 3, 4, 5, 6. So, it is a 6 into 6, which is a 36. Now, the sum of the numbers as 2, as this 2, is 1, 1, because 1 plus 1 gives us a 2, and the sum of the numbers as 3 is 1, 2 and 2, 1. Now, a question might arise that I have taken 1, 2 and 2, 1, but I haven't taken 1, 1 and again reversed it as 1, 1, because 1, 1 and 1, 1 is same, because if I roll a dice and the outcome is 1 for the first roll, and if I roll a dice and the second outcome is also 1, then it is 1, 1. But see, 1, 2 and 2, 1 are both different, because I am rolling a dice once and I get an outcome of 1. But for this case, I am rolling the dice for the first time and I am getting an outcome of 2. So these two are different, but 1, 1 we will take it only once. So sum of the numbers as 5 is 1, 4 and 4, 1. 2, 3 and 3, 2. Now the total number is 1, 2, 3, 4, 5, 6, 7. So the probability of getting the sum of the numbers is 2, 3 and 5 is 7 out of 36. So it is a 7 by 36. Question 17. It says that the center of a circle is at 2, 0. If one end of a diameter is at 6, 0, then the other end is at. We need to find it. Now, I would say that you don't have to do any calculation here. If you want to, you can. But since this is an MCQ and you would try to save time here, so I have a trick here. What you do is you do a graph which says that my circle is at the point 2, 0. So, I am plotting 2, 0. So, this is my center. Okay. Now, one end of the diameter is at 6, 0. So, I am plotting 6, 0 here. So, one end of the diameter is here. Now, we know that if this is a circle, I have a circle like this. And this is the center and this is the diameter. So, the center is actually dividing the diameter into two equal halves. Okay. So, this is the center. And this is one end of the diameter. So, from the center, I am going 4 units to the right for one end of the diameter. So to get the other end of the diameter, I need to go to 4 units from the left, from the center. So which is 1, 2, 3 and 4. So my other end is minus 2, 0. See, this is simple. Question number 18. It says that this diagram is given to us where this is the x-axis and this is the y-axis, and these are the two lines which are given to us. We need to say that if the two lines are consistent, inconsistent, whatever. Now we see that these two lines are inconsistent, but if we extend these two lines, see that these two lines are not parallel. So if we extend them, they would intersect at a point. So that point is actually a solution of these two lines. So it is inconsistent but can be made consistent by extending these lines. Okay. Question 19. It says that A is an assertion. The assertion is the tangents drawn at the end points of a diameter of a circle are parallel. And the reason of this assertion is that diameter of a circle is the longest chord. Now we know that the reason diameter of a circle is the longest chord is true. And also the assertion, the tangents drawn at the end points. Now this is a circle with this as a center and this is the diameter. And the tangents drawn at the ends of the diameter is actually parallel. So A is true and R is true. But is R the right reason for an A? No. Question 20, and this is the last question of section A. It says that A is an assertion which says that if the graph of a polynomial touches the x-axis at only one point, then the polynomial cannot be a quadratic polynomial. And the reason for this assertion is a polynomial of degree n, where n is greater than 1, can have at most n zeros. Now for the assertion, we see that if it is true or not. We are considering this polynomial x minus 5 whole square. This is a quadratic polynomial which has equal roots and the roots are 5 and 5. So it is a quadratic polynomial and the graph of this polynomial touches only at 1.5. But it says that if it touches at only one point, then the polynomial cannot be a quadratic polynomial. But this is a quadratic polynomial which is satisfying the condition. Hence, A is false and R is always true due to a fundamental theorem. Okay, so A is false and R is true.